Welcome back, aspirants. Today we will solve one question of heat, heat exchanger that has been asked in Indian Civil Service exam, okay, or IAS exam you are saying. Okay. So the question is: a counterflow double pipe heat exchanger is used to uh, heat the glycerin from 20 degrees Celsius to 50 degrees Celsius by hot water, which enters in a thin walled 2 centimeter diameter of tubes, and water leaves at 80 degrees Celsius and leaves 40 degrees Celsius. The total length of heat exchanger is 60 meter. The convection heat transfer coefficient is 25 watt per meter square Kelvin on glycerin side and 160 watt per meter square Kelvin on the water side. That means uh, water is flowing inside the tube and uh, the glycerin is flowing outside the tube. Okay. So that determines the rate of heat transfer, okay, before any fouling. That means the heat exchanger is new condition and no any scaling or dusting is on the surface. And the second question is after the fouling factor. That means uh, when there is a dusting or scaling on the condenser. Okay. So here one thing that you know is, suppose this is a tube and the water is flowing inside and glycerin is flowing over it. So there is a convective heat transfer resistance from inside as well as convective heat transfer resistance from outside, plus the conduction resistance due to the pipe thickness. But here no any mention of pipe thickness and conductivity of the pipe material. So you know the total resistance during this heat flow is heat resistance of convection from water side plus resistance of conduction, okay, conduction due to pipe thickness plus convective resistance on glycerin side. Okay. Here nothing is mentioned about resistance or any thickness, so we will take as a 0. Okay, so now we have resistance due to only uh, convective heat transfer due to water and convective heat transfer due to glycerin. Okay, so here if we plot temperature profile, okay, like temperature over distance for this heat exchanger, glycerin is heated from 20 degree to 50 degree. Okay, this is 20 degree and this is 50 degree, okay, glycerin, and it is a counter flow. So there, these are two parallel lines and water is flowing downward. Inlet temperature is 80 degree and outlet temperature of water is 40 degree. So now here we have two theta, that is temperature difference at two location of the condenser, sorry, heat exchanger, not condenser. This is called as theta 1 and this is called as theta 2. Okay. So we have theta 1 value, it is 80 minus 50, 30 degrees Celsius. Okay. And theta 2, that is 40 minus 20, 40 minus 20 is 20 degrees Celsius. So here all the value of convective transfer and now we have temperature difference. So the equation that comes into your mind to find heat transfer, that is Q is equal to UA into LMTD. Okay, where U is equal to overall heat transfer coefficient. You know very well. Okay. So what is this overall heat transfer coefficient? Equation becomes, if we neglect the conduction heat resistance, it is 1 upon H on the water side plus 1 upon H on glycerin side. Okay, so this is the, so 1 upon U and this U is when pipe is clean, so it will denote as UC is equal to 1 upon heat transfer on water side, it is given as 160, and on gasoline side it is 25 watt per meter square Kelvin. Okay. So when you calculate it, you will get overall heat transfer coefficient on a clean tube is 21.62 watt per meter square Kelvin. Okay. And now we will find heat transfer for clean pipe, that means before any fouling. This is the equation. We have a value of overall heat transfer coefficient for a clean pipe. Area we know that pi dl because heat is transferred on surface side. So pi d diameter is uh, sorry, diameter is another 20 mm, I think. Yes, 2 centimeter. It will be 20 mm. So we write as 0.02, and total pipe length is 60. And LMTD value. So LMTD value is, you can find LMTD as theta 1 minus theta 2 upon Ln theta 1 by theta 2. When you calculate this, you will get LMTD, and LMTD value is 24.66. Okay. Just you have to calculate in your calculator. 24.66 degrees Celsius or degree Kelvin is same. Okay. So just put 24.66. So you will get, when you calculate this in your calculator, you will get 2010 watt. So this is the answer of our first question. This much amount of heat is transferred during when the pipe is clean. Okay. Now, uh, what is when fouling, when pipe is fouled or any scaling or dust is there? So what happens is that is the heat transfer will become decreases gradually. Okay. So because if now we have area same. Okay. So one thing happens is Q is equal to H delta T. You know, okay, H into delta T. We require same temperature difference and we have same area, and our heat transfer is decreasing. So what happened? Why it was decreasing is, the reason is the H value is decreasing. Why? Because of that fouling factor. So we can write fouling factor. So when you find overall heat transfer coefficient in dirty pipe, it is always less than heat transfer for clean pipe because fouling will resist the heat transfer. Okay. So when you write 1 upon U, it is greater than 1 upon heat transfer of clean pipe. So the fouling factor, we can write R, okay, R, sorry, R as a fouling factor is equal to 1 upon U dirty pipe minus 1 upon U clean pipe. So fouling factor value is given to us as 0.0006. Okay, here, sorry, here. So 0.0006 is equal to 1 upon overall heat transfer for dirty pipe, and for clean pipe we know the value of overall heat transfer coefficient, it is 21.67, and when you calculate this you will find overall heat transfer coefficient for dirty pipe. Okay, and it is 21.34. And guys, you are thinking that there is a not much change in U value compared to clean. Okay, you find there is not any impact on the performance, but when you calculate the heat transfer, okay, Q is equal to, now for dirty pipe, is equal to UD, area will remain same, and for same LMTD, it is 21.34, area will IDL, D means 0.02, L is 60 meter, LMTD will remain same, 24.66. Okay. So your heat transfer, when you calculate this in your calculator, so you will get 1984 watt. Okay. This is for 35. And when you compare it with clean pipe, so the difference in heat transfer, that is 2010 minus 1984. So when you calculate this, it is 26 watt. Okay. So this much amount of uh, heat will not transfer. Okay, this is in what, when the mass flow rate are very high and the viscosities are very high of fluid, then this heat transfer heat loss. Okay, that means that much amount of heat will not be transferred. Okay, this much amount of heat will be lost. So when the mass flow rate are very high and the thickness, sorry, viscosity are very low, so then this loss in heat will become very large. Okay, so that's why it's recommended. It is recommended from the expert, that is always clean your condenser on regular interval. Condenser or heat exchanger, wherever your heat is exchanging, okay, for regular interval, for the better life of your component. Otherwise, your component will fail before its life that has been rated in the catalog or in specification. Okay, so this is the question. Hope you guys understand this question. Thank you for watching this video, and please subscribe this channel for daily this kind of question of different exams. And I have covered DRDO, ISRO, GATE, ESC, Indian Forest Service also. And if you have any doubt, then you can ask in comment section. And we are on Facebook also, so you can follow us, and I have provided link in description. That if you have any doubt, then you can ask there also. Okay. Thank you for watching this video. Keep studying, stay focused.